I wanted to do a small video talking about the application of negative contrast on signalised crossings. Now, different people treat these in different ways, so I'm talking about the way I tend to do it. I'm not saying it's right, it is the way I tend to do it. So this is an actual project I'm working on, and the existing lighting is all 135-watt socks, and as part of that process the council have asked it to be converted to LEDs, and we're going to look at the actual crossing itself. So one of the ideas behind, or the methodology behind longitudinal uniformity, behind negative contrast, is to get good longitudinal uniformity behind the actual crossing itself. So as the person approaching the crossing here will see the person or object on the crossing again as a dark object against a bright background. So having a single-sided arrangement behind the crossing helps significantly in achieving that. So in doing that, what I've actually done is I've looked at reducing the number of poles that are within the calculation, and then upgrading the lens setting to include an LED lantern. Now, this particular project, there's a couple of ways we can go set this up. There's also a bus stop here as well, so perhaps I was a bit over keen there deleting columns, but anyway, the purpose I want to show you is the negative contrast part. So what I've done is I've previously already calculated a project using a single-sided arrangement for a 3-lane carriageway in the Roadway program, and that's come up with a solution using the R5 lens, and so each of these would be could be changed to a luma. What I could also do is to use the grouping facilities, set up a user-defined group for all of those poles, and change those from a type F, which is my 135-watt socks, to the type B, which is my my luma lantern that fits the criteria of what we're lighting the road to, which is actually M3. So the road is lit to M3, but obviously in the outdoor program we're looking at illuminance. Now, from the calculation perspective, you can see that without looking at specific grids for the calculation area, that you have a high level of illuminance immediately behind the crossing, both here and here. So from that perspective, that tends to is all that's necessary. What I could do is I could put 2 specific grids or more around the actual crossing itself to demonstrate that even more. So I'm just going to go into the editing tools, and we're going to just rotate that around. We'll rotate it about the center, and then I'm just going to resize that. Something like that. So what I'm now looking at is the area that's immediately behind the crossing. And let's go and look at up to the first column. So what I can then do is to duplicate that, and then put one in front of the same distance. So I'm going to duplicate that again, and then put one in front there, which I'm just going to make a bit wider because it's 2 lanes on the approach there and 1 lane on there, and then duplicate that again, and then now obviously you can go through and add colouring to this. So let's use red for that one, and for grid 6 let's use blue, and then for grid 5 let's use a slightly different blue. Let's go with that one, and for grid 4 let's use magenta. So what I can now see, and if I go into is I can do a calculation which demonstrates that the light level on grid 4, let's just go look at what that actually is. So it'd help if I had some masking. Okay, let's just change that to masking layer 2. Yeah, that helps. 5, let's change that to masking layer 2 as well. Yeah, let's change that to masking layer 2, and grid 7 do the same. What I haven't done, which I really should, is to include set all the grid points up and so on. They're set to about ½ meter grid by the looks of it, which is probably ticking the boxes as far as that's concerned. But anyway, so I can look at grid 4, which is my grid beyond the crossing, and then compare that to grid 5, and as you can see the area behind is about 20 lux, the area in front of the crossing, oops, wrong grid, so grid 5 is about 16. Similarly on the other side, you can see there the approach is 20 lux and the area beyond the crossing is 19. I suspect that might... oh, I've got the grid in the wrong place. So I've now got the grid in the right place. So as you can see, I've now got that set up. So that's one way of doing it. Another way you could go through and do it would be to use look at the actual vertical illuminance on the crossing. This is something we used to do before we started looking at positive contrast. And I'm going to put a vertical grid across the actual carpet itself. Look at the direction we're actually considering it. Is that the right way? No, it's not. It wants to be on the other side. And then I'm just going to go duplicate that and then put another one. So this is a similar methodology to what we use with zebra crossings, which I've covered in a different video. But what I can now do is go take a look at that grid and look at the actual results, probably with a grid that's say 2 meters high. Probably way too many points there. Let's go with 5 points. Yeah, 5 will do. So I've gone to a ½ meter grid spacing, and I'll do the same with grid 4. Let's do that with... and change the height to 2 meters. So again, looking at the vertical illuminance on the side of the crossing, that is so that's another way of doing it. You obviously have to be careful with the colorings, so we're going to have different colored grids. So let's go with blue. So on this grid here, I've got sort of 20 lux over here, and then I've got about 30 lux on my vertical illuminance here, and then on grid 5, if I just go bring that up as well, grid 4 even. We can see the results on that there. So that's a couple of different ways we can look at vertical illuminance. If I'm really honest, I find the methodology of looking at the actual illuminance levels on the actual carpet here more than adequate, and that shows to me that the lighting level behind the crossing is significantly higher. You could potentially use a different contour value. I'm using I've got a 20 lux contour, an 8 and a 4, so maybe we would want to use maybe a 30 lux contour. perhaps 25. So you can see clearly there that the light level beyond the crossing is significantly higher than that on the approach, and from a negative contrast perspective that should give you an adequate solution. I hope you found that useful. If you have any questions, please drop me an email to support@lightingreality.com, or alternatively, if you have any questions or you have any further topics you want covering, again, support@lightingreality.com. Or lastly, if you want to tweet me directly, you can send me a message at nicksmith1246 on Twitter. Thank you very much.